from the board. Today's topic it is preparation and properties of potassium dichromate and potassium permanganate. These two are very important. Definitely you will get some questions from this topic. That is preparation and properties of potassium dichromate and potassium permanganate. Preparation method they may ask. Important reaction they will ask, and oxidizing properties. Definitely you will get some questions from them. Come on, let us go. And first and foremost, preparation of potassium dichromate. Let us go. Preparation, it is so simple and easy. 3 steps you have to follow. First and foremost, you have to prepare that potassium dichromate from chromite ore. So what is the chromite ore? That is iron 2 chromate, FeCr2O4. This is chromite ore. Combined with sodium carbonate or potassium carbonate with excess of air, you will get sodium chromate. You will get what it is? Sodium chromate. So this is the first step. From the chromite ore, we combine with sodium carbonate with the excess of air, you will get sodium chromate, that is Na2Cr2O4. This is combined with acidified sulfuric acid. So this is the second step. Acidified sulfuric acid. You will get Na2Cr2O7. Sodium dichromate, you will get it. Sodium chromate, it is yellowish color. Sodium dichromate, it is orange color. So this again it will react with the KCl. So if it reacts with KCl, we want what it is? K2Cr2O7. Yes, we got it. So these are the 3 steps we have to follow. Okay, those 3 steps are giving 3 marks. Definitely, how to prepare that K2Cr2O7. Definitely, you may get such kind of questions, preparation method, or else they may give that equation. You have to complete that equation. In that way, they will ask. Okay, now the first step. As I mentioned, that is the hint for you. Okay, when FeCr2O4, that is chromite ore, combined with Na2CO3, sodium carbonate with excess of oxygen, that is air, O2. So you will get Na2CrO4, sodium chromate, yellowish color. Okay, Fe2O3 plus CO2. Right? Okay, now here 4 balancing equation. 8, 7, and here 8, 2. Here 8. Right? Okay. Now come to this point. So this is the first step. In that first step, what we received? Sodium chromate. Yes, we got that sodium chromate which is yellowish color, that is filtered. Again it reacts with acidified H2SO4. So step 2, it is Na2CrO4 combined with H plus ion, that is H2SO4. Right? So what you will get? Na2Cr2O7 plus Na plus ion and H2O. Right? So here Na2 plus, yes, you will get it 2, and you will get it here 2. Okay, now this is sodium dichromate. You got that sodium dichromate. This step number 3, this Na2 Cr2O7 combined with the KCl, you will get what it is? K2Cr2O7 plus NaCl. Okay, now here 2. So naturally K2Cl it is 2. Na2Cl2, so 2 NaCl. Hope you got a clear idea how to prepare the K2Cr2O7 and this preparation method, it's very very important. These are the three steps you have to follow. For each step, one mark, and I have given the hint. I hope you got a clear idea. Okay, now we are going to see the chemical properties, that is important reaction. Let us go for it. Now let us start chemical properties, that is important chemical reaction. Okay, from the board. So first and foremost, chromates and dichromates are interconvertible in aqueous solution depending upon the pH of the solution. So oxidation state of chromium in chromate and dichromates are same. Come on, let us watch that. So CrO4 2 minus plus H plus ion, that is acidic solution, you will get Cr2O7 2 minus plus H2O. So Cr2, no, here the same way H2O. Now the second one here, Cr2O7 2 minus plus OH minus ion. You just check it where it is OH, where it is H plus ion, right? Okay, now Cr O4 2 minus plus H2O, right? Now here CrO4, no, here you will get 2, right? So here also you will get 2. Cr2, no, so you will get it 2. Hope you're clear with this. These both are interconvertible, right? Okay, now let us go and see what are the important reactions from the board. Now the first reaction, K2Cr2O7 while heating, what you will get it, K2Cr4 potassium chromate plus Cr2O3 chromium oxide plus oxygen, right? Okay, now it's not balancing, right? Okay, let us balance that. This is 4. So naturally here also you will get it 4, and here 2, and the remaining 3 oxygen, right? Okay, now the next one, K2Cr2O7 plus HCl, if you heat, what you will get it, definitely KCl is the main product plus CrCl3 plus H2O plus Cl2, right? Okay, now balance that equation. Here if you put 14 means here you will get K2, no, so 2 KCl. Then next one Cr2, so 2 CrCl3. Then next one 14 HCl, no, so 7 H2O, 7 2s are 14, right? Now here 3 Cl, 3 2s are 6. Here 1 6, 6 plus 6 12, 12 plus 2 14. Yes, Cl14. Hope you're clear with these two equations. Now let us go for that cold and concentrated. Now let us watch these two equations. Hope you're clear with these two equations, because they may give that equation while heating, what is the product, or it reacts with HCl, what is the product, like that they will ask. Cold condition, H2SO4 cold condition. So here CrO3 plus KHSO4 plus H2O, right? Okay, now here 2, and here also 2, and here also 2. Yes, you got it. Okay, now the next one, K2Cr2O7 with the concentrated sulfuric acid while heating, what you will get it, K2SO4 plus Cr2SO4 thrice plus H2O plus O2, right? Okay, now here balancing equation, here 2 and here 8, right? So here also 2 K2, right? And here also 2. Now here 8H2SO4. So here 8 hydrogen balancing and 3 O2. Hope you're clear with this all important reactions. Okay, some more important reactions, let us watch. Here K2Cr2O7 H2O PbNO3 twice. So you will get PbCrO4 plus KNO3 plus HNO3. Right? Okay, now you will get the answer here, actually here 2, and here also 2, and here also 2, and here also 2. Right? Hope you got an answer. Next one, here Cr2O7 2 minus plus H plus ion and H2O2. Actually, this equation is an example of oxidation state. Chromium in chromate and dichromate ions are same. Okay, now here CrO5, a special oxide. This is CrO5 plus H2O, right? Okay, now here this is 2 and this is 4. So you will get it 2, and here what it is? 5. So you will get 7 oxygen, 7 plus here 8. So you will get the answer here. I hope you got a clear idea. Now, actually, this is a chain reaction. K2Cr2O7 plus KCl plus H2SO4. You will get chromyl chloride CrO2Cl2 plus KHSO4 plus H2O. Right? Okay, now next one, CrO2Cl2 plus NaCl, you will get Na2CrO4 plus NaCl plus H2O. Actually, this is chromyl chloride, no? This is a chain reaction. This chromyl chloride, again, it reacts with sodium hydroxide. You will get sodium chromate. This sodium chromate, again, it reacts with the lead acetate. You will get lead chromate. PbCrO4 plus CH3COO Na. This is lead acetate, so lead chromate. Balancing that equation, now this is 4 KCl, 6 H2O and Cr2. Okay, now balancing that 6 and here 3. Right? Okay, now next one, CrO2, Cl2, NaOH. Here 4, Na2, here 2, 4, and H2O, here 2. Right? Now next one, CrO4, that is sodium Na2, Na2CrO4, sodium chromate combined with what it is? Lead acetate. So you are getting lead chromate plus sodium acetate. Hope you are getting a clear idea. This is actually a chain reaction. I hope you got a better equations, important equations, reactions. You got it? Okay, now let us go for the oxidizing properties. Now let us go and identify that oxidizing property. It is very interesting and easy also if you know those important points to be noted. Okay, first and foremost, let us go for the chromium. Okay, chromium atomic number, Z is equal to how much? 24. How to write that electronic configuration? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4. Right? Okay, how to write it? One electron can give here, so automatically it is half filled. Right? Half filled and completely filled are more stable. That is the reason we have written like this. Chromium and copper, it is actually having special character. Okay, even in our last video also we have gone through, grade 11 also we have gone through this property. Yes, fine. Okay, that means chromium is having maximum number of electron loses. 6 electrons can contribute. That means it is having plus 6 oxidation. Now come to this point, K2Cr2O7. Why did I brought this? No, you will get a better idea. That is what I just bring it to you. Okay, oxidation number, how to find out? Of course, this is very easy. That is 2 into, it is a first group element, no? So plus 1 plus chromium. We did not know. This is what we are going to get that oxidation number. So 2x we can put it because 2 it is there, no? Plus here 7. 7 into minus 2 equal to 0. So 2 plus 2x plus 14 equal to 0. So that means 2x plus 14 minus 2 equal to 0. So that means here 12 you will get it, no? So 2x equal to 12. So that means x equal to 12 by 2. 6. So plus 6 oxidation state. Yes, you got it, plus 6 oxidation state. Okay, so maximum number of electrons you can donate. How many electrons it can donate? 6 electrons can donate. Okay, now next one more point. Here K2Cr2O7 maximum number of electrons can donate. It is plus 6, right? It's plus 6 oxidation. That means oxidation it will be nil only. Why? Because maximum it can provide 6 electrons. Whereas reduction it can reduces. It reduces itself and it will oxidize for other elements. That means it is a very strong oxidizing agent. Okay, it reduces itself and it is a strong oxidizing agent. Strong oxidizing agent. Why I'm telling it's a strong oxidizing agent? It will oxidize for other elements. It will help other elements to oxidize in a better way. Okay, now come to this point. Here one point Cr2O7 2 minus. It can convert it. That means it reduces to Cr3 plus 2Cr3 plus. Okay, now this is one reaction. Now, how to write a complete reaction for this? First and foremost, I would like to mention a hint for you. So, always that hint and tricks, tips, everything will help you to understand in a better way. You know very well redox reaction. So, that is what I just mentioned. Oxidation, loss of electron, reduction, gain of electron. Oxidation, loss of electron, increase in oxidation number. Whereas reduction, gain of electrons, it is decrease in oxidation number. I hope you got an idea and you have learnt already. Yes, in this topic, a special priority will give for this equations only because for this 5 marks sometimes they will provide. Right, now come to this point. Simplifying redox reaction. How? Find out the oxidation number. Yes, we got it. Oxidation number, it is plus 6 oxidation number and identifying whether increasing or decreasing. Cr2O7. Here actually whether increasing or decreasing. Here decreasing because here plus 6. Oxidation number, it is plus 6 converted into plus 3, it is decreases. That means it is reducing, right? Decreasing means it is reduction takes place. Yes, fine. Now to balance that increasing or decreasing of oxidation number, multiply with suitable number. How to multiply with suitable number? Come to this point. Here add number of oxygen to water molecule in right hand side. So this is RHS and this is LHS. Left hand side, right hand side. Okay, now here, right hand side, how many water molecules you have to add? Add number of oxygen to water molecule. How many oxygen molecule is available here? 7. So you can put it 7H2O. Got it? Right? Now, this is over. Now, next point. Breathe yourself. And then go to the next point. Add how many hydrogen on left hand side? How many hydrogen is available? 7 twos are 14. So, here you have to write 14H plus ion. Now here, how many electrons involved in oxidizing agent? Actually here, what is that oxidation state? Here plus 6, right? So that means plus 6 electron. So plus 6 electrons means here plus 3, right? So here 2Cr3 plus, that means 1 chromium atom can provide 3 plus 2 chromium atoms. So that means it is 6, right? Okay, a way it'll rub this. I hope you got a clear idea for this. Now, how to write that redox reaction here? Cr2O7 2 minus plus 6 electron plus 14 H plus ion. It gives, here what you will write? 2Cr3 plus 2Cr3 plus 7H2O. Got it? So this is the way you have to write this equation. Hope you got a clear idea. Okay, just to make note all these things. Here oxidation point, reduction point, how to find out that oxidation and reduction, and how to add for all these points. Hope you're clear with it. Okay, now we'll go for balancing. This is actually a fixed reaction. Okay, now with this one, we are going to add something. As we have seen this equation, I hope you got a clear idea how to write the balancing equation. Okay, now actually this is a fixed reaction. Now, one more thing we have to find out, equivalent mass of K2Cr2O7. Okay, equivalent mass of K2Cr2O7. So, how to find out the K2Cr2O7? Equivalent mass means molecular mass divided by number of electrons change. That means it is an oxidation state, how much it is there, that you have to provide. Okay, you can write it oxidation state also, or else number of electrons change. Okay, so here actually what it is, molecular mass divided by 6, because the 6 it will vary, depends upon the acidic medium and basic medium. That is what I just mentioned, number of electrons change. Okay, I'll give some reaction. Now we are going to do some balancing equation. Now I have written some reactions, that is iodide into iodine. It oxidizes iodide into iodine. Okay, let us go and check it with that balancing equation. Okay, I just rub the side. Okay, this is a fixed reaction. Now this is actually, we no need to disturb, already it has fixed. Now we are going to add, this is I minus, it gives I2. Okay, I minus it gives I2 means what we have to do. So I minus 1 electron, it releases 1 electron. So what we have to do here, we have to check the number of electron. Comparing these both, how many electrons are here? 6 electrons are there. But here how many electron? Only 1. So what we have to do? We have to multiply with 6 electron. Why? Because 6 ones are 6 to compensate. That is what they have. Suitable number you have to multiply. That is the reason. Okay, suppose if you are multiplying, because it is a fixed one, you are compensating this. Okay, 6 electron, that means here 6 minus, and here already 2 it is there, so I can write it 3, and here 6. Now 6 electrons are here also 6 electrons, so I can strike out these. Now I can write that Cr2O7 2 minus plus 6 I minus plus 14 H plus. It gives 2Cr3 plus 3I2 plus 7H2O. That's all this equation. Hope you got a clear idea about how iodide oxidizes to iodine. Hope you're clear. You're getting a better idea about this equation. Okay, we'll go for this equation. Okay, now this equation, the same equation, fixed reaction. Okay, now Sn2 plus converted into Sn4 plus. Number of electrons increased or decreased, that is multiply with suitable number, right? Okay, now how many electrons here? 2 electrons, right? Sn2 plus Sn4 plus. Okay, now this reaction multiply with it. Now we need 6 electrons. So multiply with 3 electrons. Right? Now how will you add this? So here 3 and here also 3 and here 6 electrons. So 6 electrons, 6 electrons will be cancelled. So Cr2O7 2 minus plus 3 Sn2 plus 14 H plus ion. It gives Cr3 plus here 2 plus 7 H2O plus 3 Sn4 plus. Hope you got a better idea about this point. Okay, now next one H2S. Let us go for it. Now in this reaction, hydrogen sulfide oxidizes to sulfur. Now you have to balance this equation. Already this is a fixed reaction, you know very well. Now how do we balance this equation? Anyway, it releases 2 electrons only, no, because sulfur content, sulfur, oxygen, everything, it is 2 electrons only it releases. It's a mandatory. Okay, now next one, how you have to use a suitable number for multiplying to balance this equation. So which number you will provide? So it is actually 3 electrons. Why you have to get 6 electrons for that is the reason. Okay, now suppose here 3 electrons means here you will get 6 electrons and here 3 electrons means here what it is? 3 only. Why? 2 threes are 6. Okay, now here you will get 3 and how many H plus ion it releases means 6 H plus ion. Got it? Okay, now you have to write the balancing equation. Cr2O7 2 minus plus here this one 6 electrons na 6 electrons 6 electron cancel. Okay, now here 14 H plus is there, here 6 H plus is there. Now 14 minus 6, how much? 8 H plus ion. Please note that point. In that way you have to do. So 8 H plus and 3 H2O. It gives 2 Cr3 plus and 3S plus 7H2O. Hope you got a better idea. See, here there is a twist. Please check that. Here, actually, how many hydrogens are there? 6 H plus ion. Here, 14 H plus ion. So, you have to minus that 14 minus 6. Here is the twisting point. Rest of that and all, it will be same as it is. See, here 14, here also 14. But here H plus ion comes. How many number of H plus ion? According to that, you have to check. Hope you are clear with it. Okay, now we are going to see Fe2 plus 2, Fe3 plus. It's very simple. Here, Fe2 plus 2, Fe3 plus. And how many electrons it releases? 1 electron. Now, what is the suitable number for to multiply with it? 6 electron, right? Because it is 6 electron required to cancel, right? Okay, 6 electron. So, here also 6, here also 6. So, what is the answer you will get it? Cr2O7 2 minus plus 6 Fe2 plus 14 H plus. It gives 2 Cr3 plus 6 Fe3 plus 7 H2O. Hope you got a better idea about this. Okay, now this one. This is fixed already. It is fixed. Okay, now the next one. Yes. Now the next one, this is NO2 minus to NO3 minus. Here, how many electrons it releases? Generally, it is 2 electron it releases. So that means what is the suitable number to multiply with that? That is 3. Okay, now 2 electrons means here also H plus it is 2. So multiply with 3 means here how many electrons required? 6 electrons. Yes, you got 6 electrons. And here also 3 and here also 3. Here 3 twos are 6 H plus ion. So now you have to write that Cr2O7 2 minus plus of course this has cancelled 14H plus here 6H plus that means 8H plus ion plus 3NO2. See, note that point here. NO2 minus it gives 2Cr3 plus 2NO3 minus plus 7H2O. Hope you got a clear idea how do we balance these equations. Can you try this one? C2O4, it gives CO2. Can you try on your own? Please subscribe this channel and hit the bell icon so that you will get all the notification. If you really like this channel, please hit that like button. Thanks for watching.